Now this is a bit 3D. Okay, so it says here we've got a building slab has 4 columns. Okay, F1 and F2 they are 0, so ignore that. Don't consider it as it says the force is 0. The equivalent resultant force and couple moment at the origin O. So at O, this is the O point. That's where we want to find the resultant and the couple moment. So let's look at first the resultant force. So this is 3D, okay? So let us look at force, resultant force. So sum of all the force along X, Y, Z. This is 3D. I don't have force acting in the X direction. I don't have force acting in the Y direction. I've only got force acting in the vertical direction. So this is minus 50 kN because it's in the negative X, negative Y, Z direction. So I've got my minus 50 K here. This one is again negative acting vertically downward. I've got minus 20 K here. So sum of all the forces gives me minus 70 K. That's the resultant force. Okay. Now, if I take moment at point O using matrix, I can do, remember, M equals R cross F. Do you remember this? Okay, so R I can use from O to this point. This is because I'm calculating moment created by this force here. So R is from this point to this point here. And what's that? The distance given is here, 6 meter, and it's from sorry, it's not 6, it's 10. It's 10 because it is from this O point to this point here. So I'm moving from O to, let me call this A, OA. That would be in the positive X direction, and this is in X along X axis, so that would be I. So that is I10. I've got my R. Remember, I'm doing this R cross F. Okay, so I've got my R here, and the force is acting downward. That is minus 20 K. So that's here. Similarly, if I then look at the 20, so the 50 K Newton force, the X distance, that's my X distance, is 4, and my Y distance is 3. My X distance is in the positive, so that will be 4I. Let me see, that's my 4I. And my Y distance is also in the positive, that would be 3J. So that's 3J. My force is acting downward, so that is minus 5K. I am using this, okay? So sum of all forces gives me the resultant moment, which is this. So I've got my resultant force and resultant moment. So going back to the question, the equivalent resultant force and couple moment at point at the origin, we've done that. Now also find the location of XY of the single equivalent resultant force, which means how can we eliminate the moment. So okay, so let's go back. Now what? So the location of this moment. Let's find the location of the moment. So if I want to know if a moment is created at this point, sorry, somewhere in the center, very difficult to visualize, is created. So there's a moment being created by, sorry, it is at a certain distance. So basically, the turning effect is along the X and along the Y also, because I've got two components here. So if I divide my Y component with the resultant, I get the X distance. Let me, how can I visually show you this? Okay. If this is my resultant force, okay, this is the resultant force, and I've got this distance Let me get a different pen. Yes. Okay. So that's my resultant force, and this distance is my y, and this distance is my x. So the distance from y-axis is x, the distance from x-axis is y. Therefore, I am dividing the moment with the resultant to get, so the moment which is basically the turning effect along y-axis, turning effect along y-axis, okay, along the y-axis. So basically, so that would be the moment divided by resultant. If I do this, I get the distance, this one. That's the x distance I get. Similarly, if I divide the moment along x-axis, that is the rotation here. So that's component this one divided by the resultant, and I will get my y distance out. Is that clear?
सही है, नेगेटिव साइन नहीं आएगा 150 के साथ?
Negative sign with 150.
So component minus 150 along x-axis, negative x-axis. MRO.
Okay, you want minus 150 divided by 70. Is that what you're saying?
Yes, sir.
Okay, so what's the answer? Minus 2.14 meters. You can get a Nobel Prize for it. For the very first time, someone has measured distance in negative.
So ये मतलब डायरेक्शन का सर वो नहीं होगा कि मतलब ये नेगेटिव एक्स एक्सिस की डायरेक्शन में होगा जो 2.1.
No, this is the distance. This is the distance.
Okay, sir.
That's the distance. Remember, let me explain you again. Remember, I mentioned in the very start, the sign of moment is not about the x or y. It is clockwise or anti-clockwise.
Yes, sir.
Okay, those signs are related to clockwise and anti-clockwise. It is not related to the x and y, which side it is for which side, on which coordinate the force, the distance is. It is basically clockwise or anti-clockwise. Is that clear?
Yes, sir. Okay, thank you, sir.
Okay.
Sir, ये last point आप explain कर देंगे फिर से location of single equivalent for resultant force का.
You want me to explain this part?
Yes, sir. ये x और y, sir, ये एक तरह से explain कर देंगे.
Okay. Let me see if I can do it in another way. Let me think. Let me first draw something. Let me think of an example. Just give me a second. No, that's the force. Okay. I've got a force. I'm applying a force F here. And that's my distance D. Rather forget it. Do this. I've got a resultant force being applied. And the distance here is D. I want to find moment at O. Now this resultant force has got two components, that's this one and this one. Okay, so if this is the value of the x component, I will say is x1, and the value of the y component is y1. Now to find the moment at point O, what shall I do? Shall I do d into x1 or d into y1? Which one will give me moment at point O?
D into y1.
D into y1. Why did you not take this into consideration?
सर perpendicular distance 0 के equal होता है x1 के केस में.
Yes. So it's exactly the same. If I look at y, I'm looking at the y-axis. Okay. Now the turning moment y. So any force that is acting here or here, that will create the turning along y. If I'm applying force along parallel to y, that will not create a turning moment at y. You agree with me?
Yes, sir.
Okay, let me do it again. I'm looking at the turning effect at y-axis. So any force which is on either side of this line, if the force is being applied here or force being applied here, I've got a perpendicular distance. And this will create a turning moment at y. Okay, clear? Stay with me.
Yes,
okay.
sir.
So if the force is on either side of the y-axis line, it will create a turning moment. Okay, and this d is basically along the x-axis. Can you see that?
Yes, sir.
Okay, so now, so you agree with me, if the force is on either side of the line, that will create the turning moment. If I've got a force in the vertical direction, along the line, on this line, if I've got a force acting up or down, will that create a turning moment at y?
Yes,
Yes,
sir.
sir.
Yes, sir.
No,
It
sir.
won't create turning moment at y because there's no perpendicular distance.
Yes,
It's
sir.
along the y-axis line. Okay. Now, if
Okay,
I
sir.
apply force in the x direction, will it create a tendency to rotate along y-axis?
No, sir.
No, it won't. So forces along x-axis will not create. Forces along y-axis, you told me, will not create the tendency to rotate along y-axis. Am I right?
Yes, sir.
So in simple words, for rotation along y-axis, you need forces which are in the z direction. To create a turning moment along x-axis, it is basically the force along y-axis along the y-axis direction. Is that clear?
Yes, sir.
Sir, why or
That's what. No, for no, I'm not talking about the direction of force. I'm talking about the distance.
Yes, sir. Yes, sir.
Okay.
Yes, sir.